All right, so that's the problem. I hope you like it. I hope you're excited to work on it. And so now we're gonna, without further ado, start our logistic regression implementation on your favorite IDE, whether it is Google Collaboratory or Jupyter Notebook. You have the choice, but my favorite is by far Google Collaboratory. So if you love it too, follow me here. And now let's re-implement this logistic regression implementation step by step. Right now it is laying out the notebook and we're about to have it in a second. There we go. All right, so that's the whole notebook. It is in read-only mode. So right now what we have to do is to create a copy of this notebook. And to do this, we just have to click Save a Copy in Drive. And this will create a copy, as you can see, of this notebook in which we will be able to re-implement the whole model from scratch. All right, great. So as usual, the first thing we're going to do is to delete all the code cells, right? Because I want you to take action. I want you to learn by doing. So I really, really want you to re-implement all these code cells from scratch. So we're going to delete all of them. To do this, we just have to click them and then click the trash button here. Just do as I do. All right, and make sure not to delete the text cells because we want to keep that well highlighted structure. All right, feature scaling. So yes, there will be feature scaling for logistic regression, and I will explain why. All right, so now we train the logistic regression model, predict a new result. All right, and you really have everything in this implementation. You'll see that you will learn how to predict an ensemble of results. In the test set, you will also learn how to predict a single result, like, when you deploy your model in production, when you want to predict a single observation. So now confusion matrix, that's to evaluate your model. And of course, the visualizations at the end. And once again, I chose a dataset of only 2 features, right? The age and the estimated salary, so that we can indeed visualize the results in the end on the training set and on the test set. Because remember, in the plot, each dimension corresponds to one feature, and therefore there are as many dimensions as there are features. And so since we have 2 features, we'll have a nice 2D plot. And that's exactly the reason why I needed to take 2 features. But no worries, the implementations we're about to make works for any dataset regardless the number of features. And I will prove this to you at the end of this part when deploying all our classification models on a brand new generic dataset with more features. And this is how I will also teach you on how to select the best model. All right, so there you go. I hope you're excited, both by the problem case study and this implementation. And now, before we finish and move on to the next tutorial, well, I would like you to do a little exercise. Now that you saw the dataset and understands it, and since you also have your data preprocessing template, well, there you go. The exercise is, I would like you to implement on your own the data preprocessing phase up to this step, feature scaling. So basically, I would like you to implement on your own this step, importing the libraries, and this step, importing the dataset, and this step, splitting the dataset into the training set and test set, and finally, this last step of the data preprocessing phase, feature scaling. All right? So please try, use, of course, your data preprocessing template and, of course, your data preprocessing toolkit, because indeed, in order to implement that step, you will need to grab a tool of your data preprocessing toolkit, and I'm sure you will find it. So you can totally do this on your own. There is no trap. It's actually super easy. And of course, we will implement the solution together in the next tutorial. So I can't wait to see what you end up with, and I'm sure we will end up with the same thing. So let's see. And until then, enjoy machine learning.